Yeah. So these are what the level five problems look like. I don't know about level four. I think level four has phase shifts also, but um, there are the reason you know there's going to be a phase shift is because of the box next to the X, right? So that X minus, that's going to be part of the team of things that makes our graph. But when I say phase shift, if you go to the help section on Delta Math, they're going to call it a horizontal shift. So you can call it that if you'd like to. Um, but the boy, if this goes well on the first try, then I'm gonna buy myself something nice. Um, so the first thing I would do if I were you, and I see Brenny writing some stuff down, I think you're wise to do that, is you should write down this template. I'm going to explain this exactly the way that I would want someone to explain it to me, as cut and dry as possible. So let's first talk about the simple things in this. Do you need a second to write that down? A times the sine of, and then that looks a little bit chaotic in there with the b times x minus h, but the b is really going to be the one that, without some method to figure it out, would be nightmarishly difficult. Like you can actually get pretty close. I was playing around with it earlier, trying to use sort of a freestyle method, and you can get in there pretty good, but um, anyhow, B's the trickster, and then H is the phase shift. So, in if so, like if the graph moves, if I can see that the graph moved left like pi over 6 units, then my H value is going to be negative pi over 6. If I can see that it moved right like pi over 2, then my H value is positive pi over 2. And then K is what you would think he is based on your knowledge of this. It's where the midline is, right? So, like if you had like a midline that went up to 5, then you would just end with plus 5. Really, our conversation today is dominated by B and H. And B in the past has been a simple matter of you guys are kind of right in the depths of it right now, but B at this point for you has been, if the period gets half as big, then you put a two where that first box is, right? Or the box after sign. Or if the period went from like 2 pi up to 4 pi, then you put like a 1/2 there. And you guys are kind of muddling around in that right now. Where this becomes infinitely more complex if you're not careful is those two purple arrows now, those two numbers now both in play. They sort of play off each other and one affects the other. So finding B anymore is not as simple as just eyeballing it and saying, oh, the period went from 2 pi to 6 pi, so it got 3 times as long, so I'm just going to put a 1/3. That all goes out the window as soon as there's a horizontal, like a phase shift involved. Okay. So y'all got your equation written down. Let's talk about the characters and who they are. And then we'll spend necessary requisite time on B. B is the one that'll get you. So what do you think A is? You know A. We've seen this before. There's a word for it. And actually, the word starts with A. Nope, it's the amplitude. So the amplitude of the graph, as you know, is just the how far it is from the midline to the highest or from the midline to the lowest. And just make sure that with your amplitude, you're always taking the absolute value, okay? So don't ever put a negative value for your amplitude. And honestly, I don't know under what conditions you would even think in those terms, but your amplitude should be a positive number, okay? And then B, we're going to kind of skip for right now. H is the phase shift. So we can call it, I think it sounds less intimidating if we just call it a horizontal shift. Oopsie. I clearly cannot spell. And then the K we already talked about, right? What's K? The midline. Good. So the only one of these that really demands our respect and attention is B. And there's a formula for B. And I say this is the part where if you sat here for a while, and just did a bunch of problems, like nerded out for like 2 hours on these, you could eventually start to reason with the math gods. You could eventually kind of weasel your way in there pretty close, and you could get the graph you're trying to match to be pretty dang close. But if it's not exact, then it doesn't help us at all. So the formula for B, write this down because you're going to use it on, well, every single problem. The formula to find B is to take 2 pi and divide it by the period. And of course, 2 pi is because, well, the default period, bless you, the default period of sine or cosine is 2 pi. And then we're going to, bless you again, we're going to divide by what we perceive, like with our eyeballs, to see as the period of the new function. So let's take a look at this. You've written all this stuff down, right? So let's try a problem together, and then we'll probably wind up trying a couple of them together. And then anytime we have, you can try some level fives, or we can wait and try them tomorrow. It doesn't matter to me. But I'm going to get rid of some of this over here. So when I was doing these, what I found to be a good strategy for me personally was I like to write out the phase shift first. So I'm going to write down phase equals. You can again continue to call it horizontal if you like that better. And then I'm going to write down amplitude. This will become like your little your crutch. This is what you'll do on every single problem levels 4 and 5 as soon as a phase shift is in play. So you want to do them. I did them in this order just so that it would spell a word. And then the next thing I did is the midline, and then I did the period. And so I just thought an easy way for you to remember that little checklist is it spells PAMP, P-A-M-P. So phase shift, amplitude, midline, period. You can do them in whatever order you want. I don't care. It was like, that was the only thing I could think of because their PAP is not a word and whatever. You get the idea. So let's get to it. For the first time ever, I'm going to switch over here to my mouse. Um, I want you to notice that we're using a sine function, and you might wonder, why do we care? We care because it's going to determine how we perceive the graph. And so you'll notice that the original is always the solid, because you've been doing these for a while. The solid graph is the default, right? And it starts at 0 because all sine curves by default start at the origin, correct? So you have to make a choice. You have to go look around the dotted graph. This will be maybe the hardest question of all. I'm not sure. Look at the dotted graph and tell me where you perceive. If you see the dotted graph as a sine curve, where does it quote unquote start?
At pi 4.
Good for you. And that might be harder for you boys to see back there, but I hope you guys agree that the purple dot is where our graph got shifted to. You see that? So it's like we view its starting point as when is it sitting on the x-axis and starting upwards, right? That's how a sine curve begins. And so the phase shift in this case is pi over 4. So you're going to want to write that down. Good so far? These next two questions are things that you learned yesterday. So what is the amplitude of our big, tall, dotted curve?
4.
4 is correct. Midline, you shouldn't have any issues with that. What is
0.
Yeah, the midline stays, so we're just going to put 0. Period is the new one today. And I think honestly, just after a couple iterations of us, you guys are all bright here, a couple times of us doing this together, and you'll just lock into this. But what's the period? You got to look at the dotted graph to answer this question. It's not a simple question the first time someone asks you, but what I'm going to do is I'm going to use my green pen and I'm going to sketch for you what any normal person would perceive to be one period of this sine curve. It goes like this, and that's it. Right? He goes up, comes back down, cuts through 0, goes down, quadrants 3 and 4, comes back up, and boom, there he is. This x value right here is pi over 4. This x value right here is 5 pi over 4. So to calculate a period, we simply have to understand that it's where do I wind up minus where did I start, right? A period is just what we call a range. So how far is it from 1 pi over 4 to 5 pi over 4?
Well,
It is 4 pi's over 4, which we could reduce down to be what?
1 pi.
Just pi. So our period is 1 pi, like this. So far, so good? Okay. So the last thing I want you to do, so after you do the PAMP, the phase shift, the amplitude, the midline, and the period, there's one more thing that you should add to your list at the bottom, and it is what is B. And I'm warning you again, B is going to be the awkward one. And I know from having taught trig for a long time that B is the one that if you're not careful will do a number on you. But we have a formula for it. We wrote it down earlier. And remember that B can be calculated always by doing 2 pi. I'm going to write up here in the corner, 2 pi divided by the period, right? We wrote that down. And now that we know the period, what this is going to say is 2 pi divided by pi. And what does that equal? Nope.
One,
Nope.
two.
Yes. When you take 2 pi and divide it by pi, the pi's cancel and you're just left with 2. Can we agree to those terms? Good. So the B value is actually just a whole number in this case, 2. And honestly, this may not have been the best first example because not going to lie, that's kind of something that you would have seen in like levels 1, 2, and 3. We now have all the components to write our equation, and so we have everybody that we need over here off to the side. So I am going to erase some stuff because we have all the requisite information off to the right. And if I scroll this, I think it'll all stay there. So here we go. So what's going to go in front of the sign?
4.
The 4, the amplitude will go there. Right now we're playing matchup with that y equals a times sine of b times x minus h, blah, blah, blah. So we're just putting things in their proper homes. And here's the new guy for today. What goes right there? Say again. Nice job. That's our b. And what's going to go in this box after the x? X minus what? Correct. Pi over 4. And then what's the midline? 0. So I don't know why I wrote those in like that instead of like using a keyboard. But again, the amplitude is 4. Our B value we calculated was 2. For this, you're just going to use the pi button and then hit divided by, what did we say, 4? And then for the midline, we have it at 0. So you do, but again, you have to fill in all the boxes or it won't take it, right? Um, So I don't know that that one was as difficult as I wanted it to be. So let's do another one together and then you guys can try some without me, okay? This time, oh, I love this. I couldn't ask for a better example than this. So I'm gonna zoom out a little bit. The first thing I want you to notice is that it's a cosine. Why do we care?
Because where it starts
Where
on
it
the graph.
starts will be determined. Thank you for that. Good. So I've got to be careful as to what I perceive, like what is the quote unquote starting point. And again, if it were a sine curve, it would start at the midline. If it's a cosine curve, it starts up above the midline at its max. So knowing which function you're using is going to answer a big, big question that eventually you'll have. So let me erase these things over here off to the side, or all these characters here. So let's start with looking at this graph and scroll down a little bit. So the normal curve is going to start at the red dot, correct? The dotted curve is going to start at the purple dot. And I wanted you to see this because I was hoping that one of the examples I clicked into, I think quite frankly, I was going to click until it happened. I wanted you to see one when the radian axis is not in terms of pi. Because the formula still will bail you out. The formula will never fail you, but it can be weird because you're used to seeing like pi over 4, pi over 2, and these are just like numbers, but they're still radians. They're just not in terms of pi. So what is our phase shift? It's an easier answer than you think it is. In other words, how far did the red dot have to move to become the purple dot? 10. So our phase shift is quite seriously just the number 10. Right. And by the way, could you phase shift this in the other direction? Could I have phase shifted this over to the green dot? Yes. and it's all going to come out in the wash. So like what's interesting about these is these aren't the when we type in answers and we get the green check mark, that's not the only right answer. There are quite literally infinitely many right answers because it depends on like Christian might phase shift it pi over or 10 units to the right. Gabe might phase shift it 10 units to the left, and Brenna might say, well, you're both cuckoo loco. I'm going to phase shift it like 20 units or whatever. And so you can infinitely just keep moving and get creative with it. Okay. But let's stick with the purple dot because it was the first one we saw. Just be advised, I don't mean to bully you. You can go either direction. That last problem, though, was that it was kind of invisible, so we went the direction we could see. What's the amplitude of the dotted one? So we won't change. We'll just put a 1 there. What's the midline? Don't you start with me. -2. Thank you, Brenna. 2, Christian, you smoking the cracky wacky. I know it's easy to get them confused. The solid line will always be the default. Okay. It is the graph of y equals cosine x. The dotted one is the one we're trying to morph to. Period. And again, just it's hard. You got to just trust yourself on this. It is. And it's so weird to think, hi, Sutter. Good. I'm making a recording for you, but here you are anyway. So you did miss a little bit. So I'll get you caught up if I can. So, and if I can't, you can just watch. It's just a really short video. What's the period? And Brenna said it. Isn't it from purple to purple? Can we agree to those terms? How long is it from purple to purple? Seriously, just 20. And again, that's I don't know what that is in terms of radians, but that's neither here nor there. It is 20. Okay, 20 radians. But not in terms of pi is the way I should have said that. And so finally, now we have to calculate B. And who remembers the formula for B? That's it. I mean, and this just doesn't change. And this is the one without it, you're 100% cooked. So to find the B value for our equation, we need to do 2 pi divided by the period, which in this case implies that we do 2 pi divided by 20. And then just reduce that. What do you get? You get pi over 10. So the B value that we're going to use is pi over 10. Now, all of the ingredients that you see on the board are going to enable us now to type in our equation. So we phase shifted 10 units to the right, 10 radians to the right, I should say. Amplitude remained unchanged. Midline shifted down to period. You just eyeball it. B is the one you don't eyeball. There's no way we're just eyeballing that. So let's head up here. And let's figure out now how to type all this information in. So what's going to go in the first blank? Amplitude, 1. And then this is where our new guy goes, B. And so that's going to be pi over 10. And then what's our phase shift? And since it's went to the right, so it's a positive phase shift. So we're just going to do x minus 10. But just be advised, if you phase shift the other way, like if we had gone down here and we phase shifted to the left, so if we considered the phase shift being from this red to this green, then our phase shift value would be -10. And then when we go up here into the box, I'm not saying that we should, but if we did, then this would eventually become x minus -10, which when you write it out like on paper would be x plus 10. We good? But since I'm going to just keep with the positive phase shift. So we're just going to do the amount of phase shift that we did, and that's just a straight up simple 10. And then what's the midline? -2. And again, a lot of this you can reason through. The 1 is easy to see. The 10 is easy to see. The 2, the -2, whatever is easy to see. The pi over 10 is quite frankly vexing. You know what I'm saying? But that's how the magic happens. So it is pretty cool. But again, B is the guy. So formula for B, remember, is 2 pi divided by the period. And then the B is going to go in front of the argument. So it becomes like the precursor. It's part of the argument of the cosine or the sine function. So long story short, decide if it's sine or cosine. That'll tell you where it quote unquote starts. And then make your list. Do your PAMP, P-A-M-P, phase shift, amplitude, midline, period. Once you have those, find your B value, plug them back in. You guys think you got this? Okay. I don't have any level 5s unlocked for you yet. So why don't we just call it a day? or keep working on whatever you're working on if you want. And then tomorrow I'll unlock the rest of them, levels 4 and level 5. Would you like to do one of these together since you're here, Setter?
Sure.
Okay. I'll just keep recording so that since I so here, get out your notebook real quick. We can actually just kind of get this knocked out. So I'll show you the part of it that you missed.
Yeah.
How was the field trip?
It was good.
It's good.
Went to Two Doors Down and then played mini golf.
What kind of burger did you get at Two Doors Down?
Teriyaki?
Okay.
It wasn't bad.
Never had that. I always get the south of the border.
It
It comes with the jalapenos and salsa on it.
found it.
There it
It's
is.
missing.
He's had that pencil since the beginning of the school year.
It's impressive.
Did you find your eraser? I did. It was in my notebook.
Write this down. This is it. I mean, this is everything we could possibly do to a sine or a cosine function would be these, what we call transformations. So let's run down a list of the things that you're familiar with first. A, you're already familiar with who that is. He's the amplitude.
Yeah.
Make sure that you always take the absolute value. And not that you would ever do this, but you don't ever want your A value to be like negative. So if for some reason you saw the amplitude as I go down 4, the amplitude's 4, not negative 4, right?
Right.
Okay. B, we're going to not talk about just yet. We're going to talk about H. H is one of the new guys today. So H is what we call the horizontal shift. I call it a phase shift. So depending on what book or resource you're using or what website, um, I don't know, all of this put together, we're doing right now what's called a phase shift. So what's happening is you're taking a graph and you're actually changing the period of it. But if you think about it, while you change the period, you're also moving it. And all of that stuff put together becomes a phase shift. And you're like, holy buckets, how am I supposed to keep track of all this? So H is the amount of horizontal shift that the graph undergoes. And then K, you know who that is. He's the midline, right?
Right.
So the new kid on the block is B. And there's a formula for B, and you kind of saw us doing this when you walked in. B can always be found by taking the default period of a curve, which in this case is 2 pi, and dividing it by the observed period of the graph you're trying to make. So 2 pi is the default. The bottom one is what we see with our own eyes. Got it?
Yeah.
Okay, so let's go pick another problem and test it out. And then can you stay like a minute after the bell rings? 30 seconds?
Yeah, I think
I'll be
a little bit of practice, but
I'll be super fast. So
yeah.
let me make a new problem here. I think this one looks just fine. So, I mean,
11 before. The
right.
amplitude is 1.
So a lot of these I can just kind of fill in as you say them. So you already know the midline is 4. So at the back, I can just put in a 4, correct?
Yeah.
And then the amplitude is 1, so I can put in a 1. And now we need to talk about phase shift. So the phase shifting is all part of this. Again, like I said, period changing horizontal. It's all a little bit convoluted. So the normal quote unquote start of the sine curve is the red dot. The shifted start of the sine curve, you could perceive it a couple of different ways, but I personally would see it as this one right here. Do you see that?
Yeah.
If it were a cosine, we'd be having a different conversation. We wouldn't be looking for the point when it comes back up through the midline. We'd be looking for the point where it's up above,
1,
where it's
or wherever the up.
correct. So the first thing that you and I perceive is that the shift, call it whatever you like, the shift is 6 units, 6 radians to the right.
Yeah.
Okay. And then the period, we have to be able to observe, like with our own eyes, what one period is. And for the period, you could go from any purple dot to any other purple dot that's right next to it. So it doesn't matter to me where, but what is the period when you look at it?
4.
Nope. Careful. Pay attention to your
3, I guess. So 12.
correct. Yeah. So from -6 to 6 or 6 to 18, you and I can agree that the period is 12. So this all now is going to factor in. So here we go. The first thing we need to do to make this make sense is find B. And B, remember, is the default period of a sine curve.
Pi over 6.
Correct. You got it. So the B value is pi over 6. And then the rest of this we should be able to fill in. So the B value goes right here. So I'm just going to hit the pi button and go pi divided by 6. And then the x minus, since it shifted to the right, at least that's how we perceived it. You could,
Yeah,
by the
it
way,
could be left.
you could go left, and then you just have to put in a negative value for your horizontal shift. So in our case, since we shifted 6 to the right, we're just going to type in 6 and give it a shot. So that's it.
Cool.
Not much to it, right?
No.
B is the kicker. So period divided by 2 pi. Or no, 2
Or
pi,
2 pi,
2 pi divided by
period.
period. That's my bad. So got it?
Got it.
All right, man.
Thank you.
And yeah, no sweat. And we'll work on this more tomorrow, so don't sweat it. Okay.